So, hello. We're going to do this Tryhackme lab. I think it dropped out 9 days ago. So, we're going to talk about how you can crack or decipher or get the uh, how to exploit this Ecb cipher mode and exploit this weakness. So as you can see, we're going to play around with the attack box. As you can see, I already have the code. It's just that you understand how this exploit is going to take place. So we're going to walk through to what Tryhackme says. So in order that you can understand what is going under the hood, right? So the first thing is when we are going to determine the block size. So how we determine the block size of our cipher mode? Well, we are going to start like with one character, like okay. So the first thing is that we got this cipher text that is encrypted. As you can see, I think is 64 bytes long. And as you can see, it is grouped by two because these are x values. So the first one we're going to do is calculate the block size of this cipher mode. So we are going to start work try like putting different username lengths. So in order that we can understand in which length does the result change his size, like the size of the string, right? So we're going to talk about like this. We're going to uh, explain this, right? So why are we going to determine the block size? Well, because in that way we can see we have a portion of this cipher mode where we have control of that. So as this as Tryhackme says, uh, we need to increase the username length until another block is added to the ciphertext. So in this case, I'm going to play around until this ciphertext change his size. So for example, I'm working on that. I think is 17. I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So as you can see at index 17, yeah, the cipher mode increase, right? So we're going to tell that our first offset here. Let's open a new terminal. Info .txt. So the first index, let's write it here first. Index is 17, right? So what we need to do is add more length to our username in order to see in which index of the username aggregates another block. So we're going to do like this. So we have 17 letters in our username, and we are going to add five more. 1, 2, 3, 4, 5, 5, and it doesn't change. 1, 2, 3, 4, 5. Doesn't change. 1, 2, 3, 4, 5. And it doesn't change. Now we understand we are going to need to calculate the length of our string. So in order we do that, we call Python len, and we say is 33, right? So what we're going to do is accept the second index is 33, right? So we're going to calculate the block size, and the block size is equal to 33 minus 17, and this gives us 16. It's by default that I think Ecb works with 16 blocks. Well, we with a block of 16 of a length of 16. So the first thing it's done, right? Now, in order to recover our salt, what is our salt? Well, as you can see here on the Ecb of our token, is that for security reasons, when you put your username or any input on access and authorization, most of the time you the system by design add a token at the beginning and at the end of your username in order to that the how do you say it in order to enforce security, right? So after we determine the block size, we need to understand that most of the time our username is going to have a token at the beginning and at the end. So to work with and to determine how to know this token, what we're going to try to do is determine this token is that we need to calculate the offset. So the first thing that you need to understand is that the offset is the first thing that goes in our cipher. So in order to attack like this oracle, we need to, how do you say it, to find our offset. So how do we find our offset? Well, as you can see here, finding the offset is that we need to find two cipher blocks uh, identically. Like we're going to work around, right? Like this. So we need that two our blocks be the same, right? That the result of the side of the ciphertext, like here, we need to find how well um, like our how do you explain it? We're going to reach here on our ciphertext that we're going to split apart these cipher chunks, this ciphertext in chunks of the size of the block multiplied by 2 because this is x values. So we're going to get chunks, right? We're going to divide this output in three parts of chunks, and we are going to identify that the first chunk is identical to the second chunk. And when I'm talking about the first and the second one, I'm talking about index. The first chunks, it will be 0. This chunk until like this one. On if the block size is 16 and multiplied by 2, 32 characters. So for example, suppose that we are going to get here. This is our first chunk. This chunk is 32 bytes, right? And we are going to get another 32 bytes of chunks and another 32 bytes. So we are interested in the last two ones because this is going to give us exactly the same results because the two blocks are identically. So as I mentioned before, cipher blocks encrypts data independently, each block independently. So that's how that's how we are going to play it. So we are going. I know that my offset is 16 bytes, right? So I'm going to append 1, 2, 3, 4. So we are going to write. So we are going to add 16 A's because this would be like how do you say it? Our block size, and we are going to append like 16 more. 1, 2. Let me refresh it. I don't know what's going on. Sorry for this inconvenience. So in the meantime, I'm going to explain what we're going to do. So we're going to find the offset. So in order to find the offset, I need to put 32 strings of A's or different letters whenever you want, because 32 bytes represents 2 cipher blocks. So I need to add another letter, B, C, or whatever you want, and add it to the length of the username at the beginning. When we find that two cipher blocks are the same, this is where we find our offset, and we need to count the letters that are not the A's. So that is how we find our offset. So let me find, give me 1 minute. And after that, after we find the offset, now we can start our attack, right? So in this example, let's say that the offset is 4. It's different in the script that we are going to do. As you can see, we have two identical cipher blocks. As you can see, our offset is 4. So now as we know, I don't care about the second block because I have the first block, and in the second block, in this example, there is a token, and I need to find the token. So as you can see, I have this Tryhackme, right? So how are we going to know which letter is, right? So what we are going to do is calculate the offset of the. I'm going to take 1 byte here in this string, right? I'm going to take the last byte of my offset in order that this letter puts in this square, and we're going to get a reference chunks of this of the first 2 blocks. But now we know 1 byte, right? This is this t, because when we take off 1 byte, this byte comes to this, and now we have our reference chunk, right? This is our reference chunk. This is going to be our reference chunks, the B, 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 and AAAs. So this is going to be our reference chunk, and this is going to give us our cipher result. And the second result is what is going to give us our cipher and the one we need to match in the script, right? So uh, let me see. Now we are going to, as Tryhackme give us like the code to do this, but the task is to find. They give us to extract one byte, and we need to do the all the attack, right? So as you can see now, what we need to do is to extract all the bytes of the token in order to see which are the secret word, right? So the first thing what we're going to do, this is defined by functions, and the first thing is going to do is that we are going to make a post to the URL. So let me let me let me show you the code. Got Ecb script.play. So let's let's see this, right? So first we're going to give us the URL to the Python script. We have a block size of 0, and now the chat to Oracle. Now what we're going to do is make a post. So let me explain you how you can see where it's going under the hood. So this is the URL, this is the port where it's listening, and the path is Oracle. So let me this is also for the ones who don't understand request library. So beautiful sub is in order to retrieve the text, the HTML text of the web, and we can find the tags of what is inside of a text, right? So what we're going to do is to call the text in a HTML parser. This is going to give us the text in a HTML format, and then we're going to find the ID encrypted result and find a strong. So what it's going to do is that this chat to Oracle, what it's going to do is that now that we have the result, if I have opened the inspector, you will see that let me scroll down, and yes, here in the container. So here deep Carpati, as you can see. Here. So the ID of this form is encrypted result, and as you can see, that's why they put strong, because the result is in the strong like this in the tags, between tags. So it's mostly what it's going to do in the script. It's going to find the cipher text of that, and then it's going to return our value. After that, we're going to calculate the block size. As you know, we're going to enter and enter and enter again. This is what the code does is what I already told you, but obviously in automated way. And the only thing that we are going to work around is this is the same thing that we did manually. We're going to calculate the block size. The first thing is going to go at username of A, and then we are going to make a request to the uh, to the to the web page, and then we are going to get the block size. So this is not so important. if you understand loops, you will get this. It's not too difficult to understand. And as you can see, second change length, first change length is what it's going to do. The split ciphertext, what it's going to do is, as we know, the ciphertext is involved in X groups. So that's why every character or every X digit is in occupies 2 bytes. So that's why is multiplying by 2. So what is going to do this a list, a nice way to make a list. So what it's going to do is going to create a list of chunks, and then for every chunk is going to give you a block. Well, every chunk is going to have a length of the block size. In this case, is 32, and it's going to start in the 0 position of the ciphertext until it reaches the ends of the ciphertext, and it's going to jump 32 bytes every cycle, right? So what it's going to do is going to get the chunks of the ciphertext. It's going to split every chunk in 32 bytes in order to get our reference chunks. And the calculate offset is doing the same thing. It's going to fill the text, the block size with A's, and then it's going to match an offset. This if it's going to get the length of the chunks, and if one chunk is going to get when you put set, it's going to delete all the elements repeated. So if one chunk is the same, it means that we have no offset, and our payload, we can start from the beginning. If no, then we're going to add the piece, and we are going to return the offset. And this is how we get our brute forcer. Here is our chart list from A to C. We're going to add our testing character, or our initial text. This one be the B's plus the A's plus the char. And after that, we're going to get the ciphertext. We're going to send our test text, and we are going to get our ciphertext. Then after that, we're going to split the ciphertext into chunks of 32 bytes. And then after that, we're going to get our reference chunks. Our reference chunk is going to be the second at index 1. You know that list starts with 0. Our reference chunk is going to be the second one, because the first chunk is the offset. The second chunk is what we are really interested. So we are going to reference our chunk, our first chunk, our second chunk in this one, and after that, if we found the char, we return the char, and else we don't return anything. And this is the ones who this function is where we're going to work with this. Okay, so the first thing is what we are going to initial text. We have a string of none, and then after that we call it we start populated the initial text with the offset of B, and then after that we start with initial text. As you can see, for X we are only appended 15 A's instead of 16, because we need the extract the last one byte, the last byte. So we're going to explain. We're going to get our reference chunks, and then we start our brute force attack. And you can see is what we're going to need to understand is that this challenge gives you only 1 byte, and we need to recover all the bytes, right? So in order that you can see how this Python script works, are going to do Python. If anyone knows why this happens, you can put it on the on the commands. So let's start. So as you can see, we found the first character, that is the O, and as you can see, the block size is 16. The first row at position was 17. The second row was at position 33. As you can see, we got this. We got what we want. So how do we modify the code? First thing, I told you that we are going to work on the on the on the last two function, that is to extract the first byte and the brute forcer byte. So let me. I already have the script. It's not because I copy it. It's because I don't want to get so much time doing it. I'm not an expert, but I give my best. So don't start like, oh, this motherfucker copied the code. No, I did it myself. The first thing I did was myself. So first, the thing is, this is going to be the we're going to leave the calculate offset, the split ciphertext, the chat to as easy, because we don't need that, and we're going to only focus on the brute forcer function and on the last one. So first, on the brute forcing function, I told you that the char list is going to be all the characters in the alphabet, and we're going to print this salt. This salt is the characters that are found on the brute forcer attack. So for example, or for instance, we have the O, right? So we're going to first extract. Let me explain it, because here it says how. I'm going to tell you which tips give us Tryhackme, and then I will tell you how we can do it. So we got a reference chunk where the last two bytes are not part of the username, right? This is the first thing that we need to do. Get a reference chunks where the last two bytes are not part of the username. And every time that we get a character, we're going to get, instead of the 2 bytes, the second cycle, we're going to get 3 bytes and 4 bytes until our string is equal to the offset. So the first thing is get a reference chunk where the last two bytes are not part of the username. So here on the code, I get this is the one. So let me explain it for the since the beginning. Now we got our initial text that is going to get our reference chunk, the char that we found, and well, this char is not, I think it's not important. And the first we need to take is like the offset. This is going to be populated by the bees, and then we're going to populate one block except for the last byte, and then here now count is going to be how much iterations is going to get the count of the letter of every letter on the salt. Now, what is the salt? The salt is the token that we're going to recover. For example, if our token is Tryhackme, on the while, the salt is going to add first the T, then the R, then the I, then the CH, in order to get the token. Now, so the first thing is going to do is going to tell that here I added one. Sorry. So we're going to tell that while count is less than 12 because the offset is 11, we're going to do this, okay? We're going to print the initial text because this is for debugging purposes. This is, you can comment out that initial text, and we're going to send that initial text to the we're going to request, no? We're going to get that ciphertext, and we're going to split it in chunks, all right? Just as we did it in manually, right? And this is we got our reference chunks, as I mentioned before. We printed just for debugging purpose. We call the brute forcer char, the brute forcer function, and our reference chunks is going to be this one, right? The ones that we are interested in. This we are going to compare with the testing strings. So this is reference chunk is going to test. This is going to be our main. How do you say it? Our main string, and we're going to compare it every time with every single characters in the brute forcer function. The initial text will be, as I said before, what this initial text is going to be our username, and it's going to be filled with the 11 B's and the other A's. And then after that, we pass the block size, the offset, and the salt. The salt, as I already told you, is the accumulative strings of the token, right? So that's why after we call it this, we add the char to the salt, because I need to know with which because this variable is going to let me do uh, well, let me explain. This salt is, but this that's why I add the salt variable, because we need to add the first character that was recovered to your username payload. So every time that we retrieve a character, I needed to add it to the salt in order that in the brute forcer function I pass the initial text. Let me see. Well, here's now. I'll see here. So that's why I pass the salt here. Well, if length salt is 0, I just need to put the initial text, in this case all the BBBs and the A's, and the last char that is going to give us, this is going to be our test string, our test text. If that's not the case, if length salt has more characters, what we're going to do is to print the initial text, add the salt, that is the characters that we found, and also add the test chart, that is going to be all the characters in the alphabet. And if we get we print the test text the same we did before, and we compare it to the reference chunks. If we found that are the same, we return found and we return the chart. And that's why we got the salt variable. And after that we got the salt, we added a count, and we modified the initial text. And the initial text is going to get the offset plus the block size. In this case, offset is 11 and the block size is 16. Is going to give us 37, right? I think, yeah, 37. But we're going to take that. We're going to reduce the length of the initial text, because we already have some letters that we already found. So that's why we need to minus the count, minus the letters that we found. So let me test it. Python, yeah, Trinidad. So So as you can see, we found Oracles nodes, no? So let me tell you how you can find. So the first thing we do is to the offset, The first thing is all the BBs and all the Cs. This is our offset, our 15 A's, and we got our first chunk. Then after that, we get our first chunk. As you can see, we get we send another reference text, the initial text, and give us this, right? And our reference chunk is this, and found it until the R. Now, but we already know that we found the O and the R, and now instead of doing we take instead of 2 bytes, now we take 3 bytes, and then 4 bytes, and that. So this is how the script works. It's really intuitive. Please, if someone you know or you are working on on security and you have this Ecb mode, please be sure that it's no longer there. Or change your cipher mode, because as you can see, we can find this. So I hope you like it, and have a great day.